Hello, the Math Dog here. In this video, I'm going to try to show why you can use cross multiplication to solve simple proportion problems. So a simple proportion problem might look like this. X over 4 equals, say, 8 over 9. So to solve this, you can actually just cross multiply. You could go 9 times x equals 8 times 4. So then 9x is 32, dividing by 9, both sides to undo this multiplication, and what we do to one side we have to do to the other. We get x equals 32 over 9 as an improper fraction. We could make it a mixed number, but that's not the goal of this video. So there has to be a reason though why we can do this. It didn't just come from, say, outer space. So this video is going to show why we can take this shortcut method to solve simple proportion problems. So let's get started. So in this video, I'm going to show that for the equation a over b equals c over d, where b and d cannot be 0, because if b or d were 0, you would have division by 0, which is not allowed. I'm going to show that you can cross multiply like this, where you get a times d equals b times c. So again, we're going to show you why this can be done this way. So again, another example problem. Suppose I had x over 4 equals 5 over 12. I'm saying you can cross multiply 12x equals 4 times 5, or 12x equals 20. So thus, we're going to show that you can use a shortcut, cross multiplication, to solve simple proportion problems. Okay, first of all, let's review what a least common multiple is. So least common multiple of a number, I'll just say LCM from here on out. Least common multiple of a group of numbers is the smallest multiple that they share in common. So for example, find the least common multiple of 6, 9, and 24. So one way to do this, it's not very efficient, but you could list all the multiples of 6, all the multiples of 9, all the multiples of 24 until you find a multiple they have in common. The first one they have in common is the least common multiple. And for these three numbers, you have to go to 72 before you find that common multiple. So that's one way. Another way that usually works when you know your multiplication tables well is to figure out the smallest number that each of the group of numbers divides into evenly with no remainder. So again, for 6 goes into 72. I know 6 goes into 72 12 times, 9 goes to 72 8 times, 24 goes to 72 3 times. So you can kind of eyeball it and figure out what's the least common multiple using that method, and that often is a very effective method. So then there's another way that I'll talk about that you don't usually have to use that much. But sometimes if you can see no other way what the least common multiple is, this will always work. So again, the least common multiple of a group of numbers is the smallest multiple that they share in common. So the final method is called prime factorization. So first of all, prime numbers are odd numbers except for the first one too. So prime numbers are numbers that only have a whole number and a whole number and 1 as their factors. So the only factors of 2 are 1 and 2. The only factors of 3 are 1 and 3. The only factors of 5 are 1 and 5. 7 is 1 and 7, etc. So here's a list of some of your first prime factors. So back to our problem, we want to find the least common multiple of 6, 9, and 24. Well, what I can do is I can break each of these numbers up into the prime numbers that when multiplied give you this number. So for example, 6 can be broken up into 2 times 3. 9 is 3 times 3, or 3 to the second. 24 could be written, for example, as 8 times 3, but 8 can be written as 4 times 2. But 4 is 2 times 2, then you have times 2, and then you have times 3. So this is 2 to the third times 3. Okay? So how do we get the least common multiple from that? What we do is we take the highest power of each factor that occurs. So 2, this actually be 2 to the first here. This is 3 to the first. 3 to the second is higher than 3 to the first, so that's the highest power of 3 we've seen so far, and then this is just 3 to the first here, so 3 to the second is the highest power factor of 3 that we see, so that's going to get included in our least common multiple. Then we look for highest powers of 2. Okay, so we have 2 to the first here, nothing here, that's 2 to 0, or it's just 1, but there is no factor of 2 here. Then here we have 2 to the third. So 2 to the third is a higher power than 2. So 2 to the third is the highest power of 2 that we see. So we have 2 to the third times 3 to the second, which is 8 times 9 is 72. So the least common multiple of 6, 9, and 24 is 72. So the rule I wrote here is break each number in the group into its prime factors. Across the group, find the highest power of each factor. Multiplies these together to get the least common multiple. Alright, so here's an example. Try to show you the rule that I just read out to you. So we're going to do a prime factorization to find the least common multiple of 18, 24, and 54. So first thing I do is I'm going to break each of these numbers into its prime factors. So again, prime numbers are 2, 3, 5, 7, 11, etc. So 18, you could just start breaking it up into whatever factors you want, and eventually if you keep doing it you will get down to prime factors. So it doesn't matter if I start out right as long as I get the two numbers that multiply to 18. So I'll start with 9 times 2. Well, 9 then is 3 times 3, and I bring down to 2, so now I have, this is a prime factorization 18 because 2 and 3 are both prime numbers. So I'm going to rewrite this so it's 2 times 3 to the second, because 3 times 3 is 3 to the second. So this is the prime factorization of 18. Now I'll do the same thing in 24. It doesn't matter if I start with 12 and 2 or 6 and 4. I'll start with 4 and 6 here. So 4 breaks down into 2 times 2. Those are both prime numbers. Well, 2 is a prime number. And then 6 is 2 times 3. That's, both of those are prime. So I have 2 to the third power here times 3. So then 54. I have 9 times 6. That's one way to get it. That's what I'll use. 9 is 3 times 3. And then 6 is 2 times 3. So here I have 2 times 3 to the third. Now what I do is I look for the highest power of each factor. So let's start with 2. That's 2, could be written as 2 to the first. That's 2 to the third. That's 2 to the first. So the highest power of 2 I see among those three numbers is 2 to the third. So I'm going to use that for my least common multiple. 2 to the third. Now I go to 3. Here's 3 to the second. This is 3 to the first. This is 3 to the third. Well, 3 to the third is 27, but that's what I'm going to use. That's the highest power of 3 I see. And there are no other factors other than 2 and 3 in this problem. So I end up with 2 to the third times 3 to the third. 2 to the third is 8. 3 to the third is 27. So least common multiple of these two numbers is whatever 27 times 8 is, which is 6. 56, carry a 5. 2 times 8 is 16 plus 5 is 216. So least common multiple is 216. So in a problem like this, it's not immediately evident to most of us what the least common multiple is. So this method actually may save you time over just trying to list all the factors of 18, all the factors of 24, all the factors of 54, for example, and seeing which common factor comes first. All right, stop the video, and here's a practice problem. Okay, when you're done, then turn the video on and see if you agree with what I did. Okay, we have 20, 48, 81, so 20 I'm going to write as 4 times 5. And then 4 is 2 times 2, so I have 2 times 2 times 5. 2 and 5 are both prime numbers, so this could be written as 2 to the second times 5. So the prime factorization of 20 is 2 to the second times 5. 48, again, there's different ways you could do that. I'm going to do 6 times 8. 6 is 2 times 3. 8 is 4 times 2, but I can keep going with 4 because that's also 2 times 2. So 8 breaks down into 2 times 2 times 2. Bring down this 3 and this 2 here. So now notice I have 1, 2, 3, 4 powers of 2, or 2 multiplied 4 times, that's 2 to the 4th times 3. Then 81 is, this could be 9 times 9, but 9 is 3 times 3. So I end up with 3 times itself 4 times, or 3 to the 4th. So to find the highest power here, I have 3 factors. I have 2, 3, and 5 in this problem. I should say I have 3 prime factors. So the highest power of 2, here's 2 to the 2nd, but this is 2 to the 4th. That's higher, so we take that. Then we look at 3. Okay, that's 3 to the 1st, but here I have 3 to the 4th, so that's the highest power of 3 that I see. So I have 2 to the 4th times 3 to the 4th so far, and then 5 is to the 1st, but that's the highest power we see of 5, so my least common multiple is going to be 2 to the 4th times 3 to the 4th times 5. And so 2 to the 4th is 16. 2 times itself 4 times 3 to the 4th is 81. And times 5. Well, you could rearrange this. I'm going to take 16 times 5 first. That's 80. So this times this is 80. So I have 80 times 81. So then I take 81 times 80. 1 times 0 is 0, 8 times 0 is 0, put a placeholder 1 there, 1 times 8 is 8, 8 times 8 is 64, so 6,480, that is my least common multiple of those 3 numbers. I would say that's not easy to find without using this method, so if you ever got something like that, the prime factorization method might be the fastest and easiest way to do it. Okay, let's now look at an example of solving x over 5 equals 1 over 2. So I'm going to go the long way here, the way to show why cross multiplication will work, but I'm not going to solve it using cross multiplication. What I'm going to do is I'm going to take the least common multiple of 2 and 5, which is 10. So what I'm going to do is I'm going to multiply the entire equation by 10, both sides by 10. The brackets mean I'm multiplying both the left side and right side by 10. Well, that's going to be 10 times x divided by 5, but 10 divided by 5 is 2, so this is 2x. Then put your equal sign in, then 10 times 1 divided by 2 is 5, so we get 2x equals 5. So notice that's just cross multiplication there. So instead of doing this is the reason this will work, but I get 2x equals 5, then I can solve that for x by dividing both sides by 2. So I get x is 5 halves. So my point here is this is the reason it works, but I could have just done the same thing by cross multiplying. Take 2x, 2 times x equals 5 times 1, which is 5, and then we get 5 halves. Okay, so you don't have to do this every time. I'm going to add another example here. So suppose I had 3x over 4 equals 7/9. Okay, so actually what I'm doing is I'm finding a least common multiple of 4 and 9, which is 36. So I multiply everything in the equation by 36. So 36 divided by 4 is 9. 9 times 3 is 27, times x is 27x. So let me say that again. 36 divided by 4 is 9, times 3 is 27, times x equals 27x. Then over here, 36 divided by 9 is 4, times 7 is 28. So you get 27x equals 28. Divide both sides by 27 to undo the multiplication on x. So I get x is 28 over 27. So again, my point here, though, is that this is the reason why you can cross multiply, because that's actually what it looks like what we did. So notice I'm taking 3x times 9, which is 27x, equals 4 times 7, which is 28. And I will get the same thing I got over there. So I don't have to go through the formal process of multiplying through by the least common multiple. I can just cross multiply in these simple proportion problems. Okay, so now in general we're going to prove that a over b equals, if a over b equals c over d, and b and d are not 0, because that would cause division by 0, a times d will equal bc if you have this equation. So the proof is like this. or a proof is like this. So the least common multiple of the variables b and d is b times d. So like if this was 3 and 4, least common multiple would be 3 times 4, which is 12. So what I'm going to do is I'm going to multiply the entire equation on both sides by b over d, or set by bd. So that shouldn't have equals here. I should just put an arrow because it's not actually equals. It's just this. This is the conclusion from that. Okay. So now let's look what we got. So notice I'm going to actually this time multiply it out. I have bd a over b on the left side. B times d times a divided by b. The right side I have b times d times c over d. Okay, well let's look what happens here. So you have a common factor here of b. Those divide out. Anything divided by itself unless it's 0 is 1. So those divide out. Here I can divide out the d's. D divided by d is 1. So I'm left with dA equals BC, but dA is the same as AD because in multiplication the order that you multiply is not important. So I get my conclusion, AD equals BC. So what this is showing is if you have this equation, you can cross multiply to get this new equation. Okay? So let me demonstrate what I just showed using some actual equations here. So the first way, I'm going to use the property of the least common multiple to solve this, and I need to find the least common multiple of 7 and 15. Well, those two have no common factors, so what I'm end up doing here is I'm just going to multiply them together. So 15 times 7 is 105. So I'm going to multiply the top and bottom here by 105. I shouldn't say top and bottom, multiply both equations by 105. So 105 divided by 7 is 15, so this is going to be 15 times 5. So let's start again here. So 105 divided by 7 is 15 here. So I have 15 times 5x equals, and over here on the right side, 105 divided by 15 is 7, so I have 7 times 8. Well, 15 times 5 is 75, times x is 75x. 7 times 8 is 56. So now solving for x, I had to undo this multiplication by 75. I divide both sides by 75. So I get x equals 56 over 75, and there are no common factors that I'm aware of here. Factors of 75 would be 1, 5. 15 times 5 is 75, and then 25, and so I did forget 3 up here. So maybe we better check. So I have 3, 5, 15, we have 1, 3, 5, 15, 25, and 75. So now 56 is 7 times 8. Let's actually do a prime factorization of this one. That's going to be 2 times 2 times 2. But I don't have 3 as a factor of 56, so I can divide 3 into 75, but it doesn't appear as a factor of 56, so there's nothing I can do. They have no common factors, so that's lowest terms. Now, rather than having to go through this process, I'm pointing out when you have a simple proportion, you can use cross multiplication. So all you have to do is go, well, 5x times 15, that's 75x. Then multiply the other way. 7 times 8 is 56. Then solving for x, divide both sides by 75, and you get the same thing we had before, x equals 56 over 75, but you save yourself a lot of work. So if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you and have a good day.